I'm sure most of the people here are familiar with you, Bruce. Bruce has been the chief meteorologist at, I'm just reading off the bio you sent me here, the chief meteorologist at Channel 3 since 1980. Well, I'm sorry.
2002.
Since 2002. Thank you. I lost my place. Since 2002. He's been with Channel 3 since 1984, and before that he was with the Travelers Weather Service, which we may have crossed paths at Travelers at that point.
Oh, okay.
One of the things that I thought was really fascinating with the bio here is the where you mentioned flying through with the hurricane hunters with the Erica program into the which is the experiment on rapidly intensifying cyclones over the Atlantic.
Yep.
Where apparently you flew with them twice.
I did.
Into the heart of the storms.
Yeah. Yep.
That's more courage than I've shown. So God bless you. But yeah. So again, thank you. I sincerely appreciate your willingness to come and talk to us. And it's all yours. The only thing I would ask is if people that are not, if you're not talking, if you would please mute yourself. And
just for some logistics, at the bottom of your screen on the Zoom menu, you'll see a share screen, and then you can bring up the content that you'd like to bring, and everybody else will see it. And for everyone else, if you could just change your view, which from the upper right-hand side to speaker view, then Bruce will still be visible, and whatever he's sharing will be on the main screen.
Okay, I might attempt that at some point in time to see if maybe get some weather maps up there and think. But one thing I want to share is it my turn now? Can I? All right, I love it. First of all, thank you again for having me here today. By the way, you know how I got into meteorology? It was through astronomy. My dad, okay, so I don't know if you can see this. I have it on my phone, but can you make this out? That is a telescope my father gave me when I was a kid.
Oh,
yes,
beautiful.
We can see it.
Yes.
And I still have it.
Wow.
Wow.
Yeah, I still have it. I got to get it refurbished because my son actually got it out of the attic, and you know, it's part of my childhood. And you know, we were looking up at the sky when I was a kid. I got fascinated by the sky, and that turned into be a fascination of weather. And there's another photo that I have on here, which gets a little bit shows you what's on the lens portion of it. I don't know if you recognize that company or not, but if it still exists, I do not know. But that's my telescope from my childhood, probably like at least 50 years ago.
Does that say cells?
It says
V cells.
Let me get my glasses back on. It says Celsi. Looks like it's SELS. Well, maybe it's just cells. SELS. Pardon me, I'm a little tired after today's tornado coverage. But yes, cells. Does that still exist today? But in any case, you know, that's what really got me turned on to meteorology. Is my father was into science. He bought me a telescope. We started looking up at the heavens, and we share something in common. We're looking up at the sky, which, you know, I've been doing since I was a little kid. And, you know, I moved around the country, and that's how I got really very interested in weather. I was born in Chicago, and the story goes that there was a severe thunderstorm in Chicago. Now, as a little baby, strong winds came along and blew me out of my mother's arms, and I rolled across the lawn, and that probably loosened a few screws. But then from Chicago, we moved to Salt Lake City, where we lived in the Wasatch on the foothills. And I would turn around, and there would be 9 or 10,000 foot peaks. I would look down in the valley, and there's Salt Lake City. And then when I was 8 years old, we moved out to Connecticut. So I got a chance to see weather from all different parts of the country. And, you know, it's something I stayed with. I went to Lowell Technological Institute to get my Bachelor of Science in Atmospheric Science. It's now UMASS Lowell. It went through a lot of name changes, Lowell Tech, University of Lowell, and now UMASS Lowell. And that's where I got my degree in atmospheric science. And that was back in 1978. And then from there, Charlie Bagley hired me at the Travelers Weather Service. I don't know if you remember Fair Weather Charlie, but he was an awesome boss and he gave me my start in the business. So I really had a chance to work with some tremendous research meteorologists that kind of broke me into the field. And I'm talking about Ken Gary, John Erickson, Jim McDonald. Jim McDonald is still alive. He got his master's in meteorology from MIT. Bill Mammon. Bill Mammon completed the Penn State meteorology program in 3 years on a golf scholarship. He used to walk around Boston with his brother. They would play chess in their minds. Okay, imagine that. Ken Gary is a Mensa member. I guess that's the top 5% as far as the smart people go. And like I said, Jim McDonald got his master's in meteorology. So they took me from the world of academia to the real world of weather forecasting in 1978. And at that point in time, I got a chance to brief Hilton Cataly. Remember good old Hilton? I worked with him from 1978 until 1998 when he retired. So and I stayed with Channel 3 ever since. Channel 3 has been my only station that I've ever worked for, which is really unusual in this business. A lot of people move on. I mean, I worked with Gail King. I worked with, believe it or not, Bill O'Reilly. He actually got fired from Channel 3 years ago. Don Lark, you name it. Denise DeCenzo, of course, who we lost a few Decembers ago, which is still something that's hard to get over. But I worked with all these amazing people over the years. But you talked about this one project called the Erica Project, and that really was the highlight of my career, because in the Erica Project, I was able to participate as a scientist and also get a multi-segment series for Channel 3. Now, the Erica Project was back in the winter of 1988, 1989. And here's how that my involvement came about. I went to a weather conference in New York City, just, for educational purposes. And the lead scientist of the Erica Project, his name is Carl Kreitzberg. He was from Drexel University in the Philadelphia area. He was the lead scientist, and he gave us a lecture about the upcoming Erica Project. And I asked all kinds of questions. So after the meeting, I went to the bus stop to catch my bus. He was waiting for his bus right next to me. And I said, I really enjoyed your talk. And he goes, you're that guy from Connecticut that was asking all those questions. And I said, yes. So he said, how would you like to be involved in the Erica Project? And I said, are you kidding me? Sign me up. So I went back to Channel 3 and I made the pitch and we got involved. We got a photographer who's still with us today. His name is Andy Halpin. And basically what it involved was, it was a winter-long project at there was 8 missions from December through February, an $8 million project, and it involved flying P-3 aircraft out of the Brunswick Naval Air Station in Maine. So we had to travel up to Maine. Now, the first storm that I flew in was in December of 1988. And that storm, we flew 500 miles out into the Atlantic Ocean, and we saw sunrise out there, which was amazing. And we caught up with the storm out there. And we were able to fly through the warm front, the cold front, and find all of these various weather features. My job was to drop sounding equipment, what we call drop sounds, from the airplane down into the ocean. They're parachuting along the way and sending information back to the aircraft. That way we could kind of locate where we were in relation to the warm front, the cold front, and other weather features. So that storm wasn't terribly rough. We got, a lot of good data out of it. Came back and did a 2-part series on it, my involvement in it. And then the second one was, I believe, the final mission of the Erica Project. That was in February. So again, we flew out of the Brunswick Naval Air Station. And this time we flew south from there to catch up with the storm that was off the Virginia coast. So we flew down what is called an occluded front. So an occluded front is basically where a cold front catches up with the warm front, but there's a wind shift along that front. So here we are flying from east to west toward the coast of Virginia out in the ocean, flying along the occluded front. The winds were meeting like this, okay? And that aircraft was bumping around like you couldn't believe. I would look off to the north. It was black as could be. I would look off to the south. The sun was shining. I would look 1,000 feet below and the ocean was all turbulent. So we were bouncing around. Anything that wasn't tied down was flying into the aisles. The guy that was sitting next to me, we were looking, you know how they have that certain bag on an airplane? I was looking at him, he was looking at me, who was going to grab it first. But meanwhile, up in the cockpit, these pilots are going like nothing was going on because they're used to flying into hurricanes. These are Hurricane Hunter aircraft, P-3s. They're also used for submarine surveillance, but these Hurricane Hunter aircraft were used for the Erica project. One would go out, come back, another one would go out. It was very much involved. In fact, the first plane that I flew on, it was like a notch in a gun where it has all the hurricanes that plane flew into. And one was Hurricane Gloria, which hit Connecticut back on September 27th in 1985. And that's the same week that my first son was born. So I remember that week very, very well. So that kind of hit home. Flying out an aircraft into winter storms on a plane that flew into Hurricane Gloria that affected my life tremendously back in 1985. So I got a multi-segment series out of it. And the nice thing is that so many people were involved in this project, not only Drexel University, but the Office of Naval Research. Why? Well, because ships are subject to these Erica type storms out in the Atlantic Ocean. And if it's cold and there's spray, the guns on the ships, the turrets and other parts of the ship can get ice heavy and potentially flip over and sink. Also, there was an oil rig called the Ocean Ranger, which was off the coast of Newfoundland. It got caught up in this Erica storm and it sank, and 80 some odd lives were lost. So the whole mission of the Erica project was to find out, how does the ocean interact with the atmosphere to cause storms to develop explosively, what we call bombogenesis, off the coast of New England. There's no other place in the world like it except for the coast of Japan. So we live in a very, very unique part of the world. For example, the blizzard of 1978 that buried Connecticut, and El Grasso had to shut down the state because that storm was so bad. That was an Erica type storm. So it can paralyze many Northeast cities, Boston, New York, Hartford, New Haven, Bridgeport, Washington, D.C., all at the same time. That was the goal of the project, to find out all these mesoscale features in a large storm. What's going on in a small part of that storm that adds to the whole. And then go back to the colleges and universities, enter that into the computer generating models that help us forecast weather, like you've heard of the American model, the European model, and all that, and to make forecasting winter storms better. So, I think in the long run, the Erica project did help with that. I'm waiting for an extension of that Erica project because even though I'm turning 65 in June, I would still go on that airplane in a heartbeat. Now, the Erica project was an extension of what they called the Gale project, which was done earlier in the 1980s. Gale stands for the Genesis of Atlantic Lows Experiment. And what happened in that project is cold air can get funneled southward along the Appalachian Mountains, and then it comes out over the water, gets funneled out over the water over the coast of the Carolinas. And you get the right jet stream dynamics coming into that, and that's where storms could often start to form. So the Erica project took it one step further. All right, those storms form to the south. Why do they develop into these monster snowstorms that can paralyze the Northeast? So that was an amazing project for me to be involved in. It really is the highlight of my career. I forecasted tornadoes, I forecasted hurricanes, and winter storms and blizzards. But as far as being involved in a project like that, it's kind of a once in a lifetime experiment, and it just fell into my lap by happening to stand next to the lead scientist of the Erica project. And saying, hey, you're that kid from Connecticut that asked all the questions. And it just snowballed. It snowballed from there. But it all began with that telescope back when I was a kid. In fact, Denise DeCenzo did a story on me when I had my 40th anniversary at Channel 3 a couple of Novembers ago, and she was very interested in that telescope, and she said, "This is the telescope that Bruce's father gave him that got him involved in weather." God rest her soul. I miss her so much, and I'm sure a lot of you and other viewers miss her as well. But we're carrying on very well here at Channel 3. So, my role right now is I'm the chief meteorologist. I've been the chief meteorologist since 2002. I've done every shift you can imagine. I did weekends for 14 years, and my wife's family, who comes from the Cape, I worked every weekend, and my wife and the kids would go to the Cape and they'd say, "Who's this phantom husband of yours?" Because I never would be able to go with them. I worked mornings for 4 years. When Hilton retired in 1998, I became the morning person, like Scott Haney is now. And they brought in a guy by the name of Miles Musio for 4 years. Well, after 4 years, he went back to Bakersfield, California. And in 2002, that's when I became the chief. So I've been working the 11 o'clock show, the 5 and the 6 and the 11 now since 2002. Here it is, 2021. And come July 1st, I'm actually going part-time. I'm going to start scaling back. So July 1st, no more 11. I'm going to come in the afternoon. I'm going to do the 5 and the 6 and some other things at 6:30. I'm done. So that's just a way of scaling back instead of full out retiring. But I'm in my 43rd year of forecasting weather in Connecticut. Again, a very unique career in the fact that I'm Channel 3 through and through. No other station have I worked for, not Channel 61, Channel 30, or Channel 8, Channel 3, all the way. One thing that, and I'll try to maybe dig up some models and things like that. But for now, why don't we ask me some questions? Because, I'm very interested in astronomy. In fact, are any of you watching on Apple TV right now For All Mankind? Are you aware of that series?
No.
Oh my gosh, it is fantastic. In fact, it's on Apple TV. It's called For All Mankind. And it's about an extension, excuse me, of the Apollo program. And it's fiction, it's science fiction, but there's also familiar names like Richard Nixon, Ronald Reagan, all involved, Buzz Aldrin, Neil Armstrong. So, they get up into like Apollo the 30s, and it's kind of an extension of the Apollo program going into the space shuttle, eventually the Pathfinder program. They've landed, I don't know how many men and women on the moon on the show, but there's all these side stories that make it a very riveting series. And I'm on season 2 now, and my wife joined me on season 2, and she says, "Nah, I don't usually like to do that," but she can't get away from it. It's really that good. It's good science fiction that also has some reality in it. So if you're really interested in that kind of a thing, and I think eventually they're going to be going to Mars, but I'm not 100% sure. I'm still watching it. It's usually about an hour long. So, I go home at midnight and I'll turn it on, and before you know it, I'm falling asleep on the couch, and then I get up and go to bed, missing half of the program. So that's the problem with working the 11 o'clock show, is that I go home, I'm wound up, the adrenaline's going.
You can't go to sleep.
I can't go to bed right away.
Well,
so
just keep that in mind when you retire, because after 11 o'clock, you're missing your astronomy hours.
I know.
So Richard Moser had his hand raised. I'm not sure if it was because if he was answering your question that yes, he watches that show, or if he has a question.
All right, Richard.
Remember to take yourself off mute there, Dick.
I'm also
Sorry, no
gonna-
specific question at this time. We really appreciate your talk, Bill. Thank you for sharing this information. That's exciting news.
Oh, you're very, very welcome. My pleasure. I'm going to try to get back to where I was here.
Okay. And while you're looking for that, the Celsey was a Japanese telescope manufacturer, and there's an eye on the end. It probably started in the 50s. They made all kinds of telescopes, from the refractor like yours to catadioptic, with or Newtonians with mirrors in them.
Okay.
So you might want to hang on to it. It has the 0.965 style eyepieces rather than the more common 1 1/4. So you won't be able to get replacements for them, but you probably have enough now to make it worthwhile.
You can probably find some on eBay.
Yeah, just don't
If you're,
start
if you're
washing your telescope lens in the sink. There are
Yeah.
No, I will not do that. I promise. Can you, by any chance, see the screen that I put up there?
I haven't seen you. Did you hit share screen yet? There it was
Yeah.
coming
there it is. Yep.
right now.
Okay. All right. So this works. All right. Good.
Yep.
What you're looking at here is one of the models that we look at. This is from a model called the GFS, and we're looking at in what the atmosphere is supposed to look like according to this computer model for Sunday, the 25th of April at 7 p.m. Okay, so 2300. Well, wait a minute. No, I'm sorry, 11 p.m. Okay. So that's UTC time. So yeah, we are talking about 7. Yep, we are talking about 7 p.m. -4. So 0Z would be 8 p.m. So what you're looking at is a storm off the coast, and this is the storm that's going to give us rain on Sunday. And I could take you through all the various steps here. Do you see it moving along okay? And this is one of the models that we look at. So now we're getting into the 29th, Friday, the 30th of April and beyond. This particular model, the GFS, which stands for the Global Forecasting System, goes out to basically 16 days. And you can see the pressure systems, the ISO bars. You can see where the green and the blues and all that's rain, or in the colder air, snow. So, we can actually take a look at this and put it into motion and just let it play itself out over the next 16 days. That's the front that just went through today that turned us from the mid and upper 60s to the 30s and 40s that we have in the state right now. There was a sudden drop in temperature. And of course, it was that contrast that brought us all the lightning and thunder. Where you see the blue lines, those are what we call thickness lines, where, if you take a certain surface in the atmosphere, there's pressure surfaces. And if you take a look at paper, think of it as a pressure surface. Can you see me as well?
Yes.
A pressure surface, like let's say 500 millibars, can look something like this, where it's higher in some locations, lower in other locations. And that all depends on the mean temperature within that given layer. So in the blue lines where the atmosphere is colder, that particular layer is lower, closer to the ground. And where you see the reds, and I'm going to stop it right here, and I'm going to show you why I'm forecasting something for next week that I think you might find it a bit too early, but we're going ahead to Wednesday. This is 12Z, which is 8 o'clock Wednesday morning. And you'll notice that we have 3 red lines over us. So what I do here is I also look at a prog aloft to see what the temperature aloft might be, because what happens aloft has a tremendous impact on what happens near the ground. Basically, what happens aloft, there's a reflection on the surface and vice versa. So I looked at this and I said, well, the temperature at around 5,000 feet, 850 millibars or so, is rising. And the temperature there is about plus 12C. So if we take what they call a skew T chart and go down from 5,000 feet down to the surface along what we call a dry adiabatic layer that equates to the low 80s. And I'm forecasting 82 for next Wednesday. So essentially, we're going to go from March-like temperatures tonight and tomorrow. Tomorrow, we may not get out of the 40s in parts of the state, anywhere from 46 to 52. And by Wednesday of next week, we're talking about 82 here in Connecticut. So these are some of the things I look at. This is a surface pattern with the 1,000 to 500 millibar thickness. Again, if it's cold, it's more compact because the atmosphere is more contracted. Okay, the air is denser, and the warmer it gets, the more it expands. So the distance between 100 millibar surface to 500 millibars is greater during a warmer situation versus a colder situation. So we have to look at not only what's going on at the surface, what's happening aloft, 5,000, 10,000, 18 to 20,000 feet. And it becomes a very involved process with weather forecasting. So, when I come in the afternoon, usually it's like today, I came in around 1 o'clock because I knew we were going to have some bad weather. And there's a lot of work that we have to get out of the way, a lot of writing. We do a technical discussion and all that. But on a normal day, I come in and I spend time with the models, coming up with the forecast. And then I have to make all the graphics, the 7-day forecast, 3-day forecast, tonight and tomorrow, based on everything I'm looking at. Now, the models are used as guidance. There's times when I say, I don't know, I don't think that's going to happen. I'll go against it. Like, for example, the National Weather Service for next week is forecasting 68 for Wednesday. And I'm thinking, what are they looking at? I mean, I'm thinking, 80 or higher for next Wednesday. So everybody looks at these models and comes up with a different interpretation of the same data. It's like somebody reading a book. What's your interpretation of the book? Even though it's the same book, you might have a different interpretation of it. So certain models will have their strength. Let's see if I can pop up a different model here called the European model. And there we go. This is a different look. So I'm kind of taking you through time. There's the cold front moving through and away. A lot of blue lines coming our way, meaning it's going to be cold tomorrow. Then as I take you through time, here comes Sunday's storm with rain. And then the European model as well by next Wednesday is forecasting these lines of a lot of red, very similar to the GFS model. So what we look for is consensus among the models that gives us a degree of confidence. So I feel very confident in forecasting 80-degree weather next Wednesday because there are several highly trusted models that are doing that, but they're not telling us how warm it's going to be. I have to go in there and look at what's happening on the surface, what's happening aloft, and say, hey, if we have a lot of sunshine, we could get it to 80 degrees or higher. And that's essentially how I reasoned 82 for a high. Could it be a little lower? Yep. Could it be a little higher? Sure. And it all depends on cloud cover. Clouds, wind direction, all that comes into play quite a bit. For example, this time of year, you could have temperatures in the upper 50s in Groton and have a temperature of 78 at Bradley International Airport in Windsor Locks. We saw that happen today. While Windsor Locks got up to 69, Groton only got up to 58. And it's all about the wind because the water temperature in Long Island Sound is in the 40s right now. So we have to take into account wind direction. Now, let's say the wind was from the northwest today, then we'd be forecasting 65 to 70 for Groton. So there's a lot to look at to come up with a forecast. There's a pretty good workload that comes up. We have to satisfy not only Channel 3, but the Norwich Bulletin. They want a blurb. We have to write a technical discussion for WFSB.com. And there's just a lot to do in the course of the afternoon. And that's why I usually come in pretty early just to be able to get all that done. But it's a lot of fun. I love weather forecasting. One of the websites that we do look at quite a bit is out of box, which is Norton, Massachusetts. It's really the National Weather Service out of Boston. And what you see here in that purple area, that's a freeze warning for tonight. So, go in there and see the freeze warning is in effect from 10 o'clock tonight until 6 a.m. So here we are, we're in the growing season. And you got the tulips and daffodils and all the magnolia trees and beautiful trees flowering this year. The forsythia are out. And some people may have planted tender plants because we've had a lot of days in the 70s and a lot of people get tempted and put some plants out that are susceptible to freezing temperatures. And, that's why we have a freeze warning in effect for tonight. So there's an awful lot to look at, when it comes to putting together a forecast. And, one of my really good friends, in fact, he was my best man at my wedding, is Joe Fury. Joe Fury now is a co-chief meteorologist at Channel 8. And for the longest time, he was with WTIC radio on the Ray Dunaway show. But Joe and I are alike. He's a little bit younger than I am, but we call ourselves instinctive forecasters. It's like you just get this gut feeling that something's going to happen no matter what the models are saying. And sometimes it works, sometimes it works against us, but I'll take chances. I'll go against the grain, like forecasting 82 for next Wednesday, and see how it's going to happen. Now, one thing that I have to be very careful with forecasting is if something is a week away, I'll get very bold. And then as time gets closer, we might start shooting some holes in that forecast, and I may kind of like pull back. And then sure enough, when I do that, it turns out to be 82 degrees. So weather forecasting is difficult. We're not just taking looking at the models and saying, yeah, that's going to happen. We're looking at a lot of things, putting our own input into it, and coming up with a forecast in a reasonable amount of time. We don't have a lot of time to do it. It's something that we have to get done, and I had to get it done early before that tornado warning came out at 2:47 in the afternoon, and then everything else gets set aside because once we're with a tornado warning, we have to stay with it until it's over. It's as part of public safety, we have to stay on. And the other thing we're dealing with is the public. People get mad if they're in New Haven and there's a tornado warning in Kent like we had today. They'll say, look, it's not bothering New Haven, get off the air. But we can't. We have to be on. So we have to have a tough shell because we get some people mad, some people are very happy with what we do, but you can't please everybody. So you have to have a tough skin, a tough shell when it comes to weather forecasting, because when I'm wrong, a lot of people, tens of thousands of viewers know it, and that can be pretty embarrassing. And if we're right, a lot of people know it, but it's some people think that we could change the weather, which we really can't do. And of course, the other major topic that we're dealing with now is climate change. I'm convinced climate change is happening. There's no doubt about it. But I'm not completely convinced that we're the sole cause of it. And I'm sure as scientists as well, you can appreciate that, there's been times in the past where with or without human beings that have been warmer than what we have right now. So I think we're in a natural cycle that's being enhanced by human activity. I really, truly believe in that we have something to do with it. Could it snap back the other way? Sometimes it's almost like a rubber band effect. Sometimes the atmosphere will stretch so far in one direction and then it will snap back. If you ever saw that movie, what was the name? Where all of a sudden it got really cold and there was snow in July. I'm trying to think of the name of the movie. But there's a theory that it's based on a theory that, what was his name that was on TIC radio? He dealt with all these science. It was late night. It was a late night program with Art Bell.
Oh.
Okay. All right. A little bit wacky sometimes, but he dealt with some interesting subjects. And when I was working the morning shift, I would listen to Art Bell on the way in. And he talked about how there's this one theory where the Gulf Stream may eventually divert eastward from the Carolina coast, and that will allow the northern latitudes to get very, very cold. That cold air would become unstable and descend southward and chill down the globe. So that's based on a scientific theory. So let's see if, there we go. I don't want you to keep looking at that boring map for forever. So, there's so many theories that go on. Will we turn colder in the future? It's entirely possible. A lot of it depends on the sun. I heard that you might be able to shed some light on the subject as well. But according to my understanding, is that the sun could go into something similar to the, what do they call it, the molar minimum that we had back several hundred years ago, where it became very weak.
The solar minimum now. We're coming into a increased solar activity period.
Okay, so we're coming out of the minimum now. There was a theory that I heard that we might be going into a period of low solar activity that could actually make us chill down over the next 40 years. But now we're getting into the increase. So, I mean, that's something that I heard, maybe that was from years ago. But the topics really change. I remember I've been in this business long enough where back in the 1970s, when we had the Civic Center roof come down and, we had the blizzard of 1978 and all that, scientists were talking about a mini ice age coming our way. And then it became global warming in the 1980s. Now it's climate change. So at what point do we go before things snap back? It's really hard to say, And the other thing is, what caused this in the first place? Is it warming that causes the increase in CO2 and other greenhouse gases like methane in the atmosphere? Does that start the process, a natural warming phase? Or is it the increase in carbon dioxide and methane that causes the warming to happen? It's like, what comes first, the chicken or the egg? I posed that to a scientist at Yale University, and he really couldn't answer that question. So, what do we have to do with it? One scientist, I think what was his name? Art Horn. Okay, Art Horn was a meteorologist on Channel 30. He said if you took a football stadium of 100,000 people and each person represented a carbon dioxide molecule, only a small percentage of that would be people would be the contribution of carbon dioxide from mankind, what we call anthropogenic global warming. So it's a very interesting science. I look at it this way. I say, why not play it safe? If we're reducing carbon dioxide, we're reducing other pollutants, and that could be as harmful. So, just in case, why not? Why not? I'm not a person that likes to dispute global warming. I'm totally on board with it. I don't like all the negativity that necessarily comes with it, because there are benefits to global warming. There are some negative things that happen. There are some benefits as well. For example, if you take the Hadley cell is air that comes from the equator and moves poleward aloft, and down near the ground, it moves from the pole back toward the equator. Of course, you have the jet stream and the westerlies in between. But if you decrease the temperature between the equator and the poles, there's a theory that you could decrease the energy that fuels storms, because what fuels storms is temperature contrast. And if you reduce that temperature contrast, could you have less storms? Possibly. So there's all kinds of things that could happen. It is a very delicate balance. If you've got a volcanic eruption that sent, let's say it lasted for years, that could throw a lot of debris and dust into the atmosphere. We had that, I believe it was Mount Pinatubo back in the early 90s. And lo and behold, we had one of the coolest summers on record just 1 year later. So there's a lot of things that could happen that will throw a monkey wrench into these models that forecast climate change and warming. And not everything is bad. You can extend the growing season. It could start earlier in the year and end later in the year. Your last frost comes earlier. Your first frost comes later. That could extend the growing season, and that could help to feed an ever-growing planet. Trees and plants live off carbon dioxide, and that could make gardens lusher, for example. It's almost like fertilizer to trees and plants. So I kind of weigh both sides. That's almost like how I handle weather forecasting. You have to be a doubting Thomas. What's right with the models are saying? What's wrong? What do I think? What are all the possibilities? So I have an open mind when it comes to all these various topics of weather. It's very interesting, though. I mean, it's something that everybody talks about. It's a water cooler subject. I'm sure astronomy is too. That's something I'm extremely interested in, because I remember through that telescope that I showed you that, I was really excited when I saw the rings around Saturn and the moons of Jupiter, and I was able to look at the moon and see all the craters. But the only problem with that telescope is, I even saw the Andromeda Galaxy. I was able to spot that. I'm sure this is like, astronomy 101 to you. But when I was a kid, that was really exciting to see a distant galaxy. And, it's just a fascinating science. And
They're still exciting. They're
Yeah,
like old
They
friends.
are. They
They're
are.
like old friends.
oh,
Yeah.
I know. So
Yeah.
tell me more about what you do. I want to also learn about what you do, and how many members you have, and do you have events where you get together and you do stargazing? I like to learn a little bit more about what you do too.
Sure. I mean, a lot of that is the answer to that really is different because because of COVID nowadays.
Yeah, that's true.
Typically, if it wasn't for COVID, we'd be having on-site meetings every month. We'd be having observing parties fairly on a fairly regular basis, at locations around the state. We have a, I guess you call it a partnership with Wesleyan University, where we open up their 20-inch telescope to the public for and we man the telescope, and the public is invited in, and a number of our members man the telescope. It's a museum piece. It's at this point it's 105 years old.
Oh my gosh! Wow.
And outreach is a big thing that we do also. We do outreach again in normal times. We do quite a bit of outreach, anywhere from probably 8 to I would say 18 outreach events a year, to libraries and scout troops and other organizations. But again, these are not normal times.
Yeah.
So we do what we can remotely.
Mhm. I know
Hopefully
it's a new way of life, isn't it?
it really is. Hopefully things will start changing, back to the way they were soon, so that we can get back on with our lives.
Mhm.
But yeah, we're we would like to start getting together again, as much as we can.
Mhm.
There's places around the state where we have tried to get together again during normal times, as a group, and just do observing. And a number of our members are fairly adept at astrophotography too.
Oh my gosh.
So yeah.
So I'm
And
sure. What kind of equipment do some of your members have?
any, and really they run the gamut from from really basic beginner equipment, which I kind of I probably I don't know what John's holding up there, but I probably count myself as as basically an advanced beginner at this point. To I joke, that some people, when we go observing, they'll pull up in a $20,000 car and pull $30,000 of equipment out of that car.
Wow.
With
This was from an event we held in 2002 at Leesburg. And
okay,
Oh,
I can go this way. And well,
there you go.
I think that's one of mine there.
Oh, there you go.
oh my gosh, that's huge.
Yeah, it's a 16-inch.
Yep.
Oh my goodness.
That was
Yeah.
held in Meriden.
2002, right? Oh my goodness.
That was at
Yeah.
the Memorial Curtis Cultural Center in Meriden.
So you've been involved in this for a long time then. It's, if that's going back to 2002.
Oh yeah, this group's been formed in the 60s.
Mhm.
And we're not even the oldest. But what I wanted to contribute to Chris's conversation is that I have 5 different other clubs around 4 different states that I've invited here, and we're up to 22 participants now, from Rhode Island and Massachusetts, Vermont, Connecticut, and even Western Hawaii. But we share. And we share events. And if it weren't COVID, we would be participating by saying that they had a big event and all these people are welcome to attend it. Or we're having a small event and you pick some friends and say, hey, you want to come observe with us this weekend? Bruce has said it's going to be clear. And that's what we'll do. Of
Right.
course, we'll check the models. We have astronomy apps for weather too, like Astrospheric and the Clear Dark Sky Clock. And
Oh goodness.
and then we'll check with Chief Meteorologist Bruce Beast, see if things
See if
match
your
up,
other- yeah.
compare our models together, and we'll get together, make a plan for, if not Friday, how about Saturday?
Yeah.
See, what we do goes hand in hand. I mean, in order to forecast the weather, we have to look up, and you depend on the weather for a nice clear night. I would take it that winter offers the best viewing. Is that true? Clean air. And,
I would say that. Sorry, John. Were you going to?
Go ahead.
I was going to say that every season has its advantage for viewing. Winter probably offers the clearest air.
Mhm.
I think that's what he was getting at.
Yeah, that's probably true. Summer, obviously the air tends to hold more humidity.
Or right after a storm.
Yeah. It clears right
Yeah,
out.
you're right. Right after a storm, the air is very clear. Spring, right now, the air tends to be really nice. The objects that we can observe are different in each season, which is nice. There's a whole different set of things we can look at. Spring is galaxy season.
Okay.
Summer brings out I don't know, John, what does summer bring out? Well, let me start with winter. Winter is the
summer Milky Way too.
Summer Milky Way, true, yeah.
And globular clusters, and
right.
Of course the summer triangle and everything is up there.
Yep. Winter has the Orion Nebula. So every season is different. Winter you're dealing with the cold. Summer you're dealing with the bugs. There's a challenge with every season too. But yeah, generally, as a rule of thumb, I think you're right. I think the air is probably clearest in the summer. I'm sorry, in the winter.
Okay. I would imagine even now as well, because you could get these days where, it's in the 70s, but you have dew points in the 20s and 30s.
Yeah.
That's the nice thing about March and April is, you can get these really mild days, but the humidity is just very, very low. And in fact, I imagine outside right now, there's some pretty good clear sky in parts of the state with these thunderstorms kind of cleansing the air. And now you got the dry air coming on in. But
It's-
I remember those
it's-
days in the winter where it was just awfully cold to
Oh,
stay
yeah.
out there, even though the stars were just sparkling.
Yeah. It's interesting though, because a lot of times you'll go out and it'll be just this beautiful clear day, and you'll just be waiting for the sun to go down, and it'll get dark, and all of a sudden it'll cloud up.
Yeah. Yes.
It's interesting the way that the air is in New England, or at least in central Connecticut. It seems to a lot of times the the evening sky tends to bring, I don't know if it's just the cooler air, makes the humidity up, or
What we do look for, sometimes a lot of changes in the weather occur around sunrise where, you get the fog but this time of the year, when the water is really cold in Long Island Sound, one thing that can happen is if you start getting a warm front coming in and higher humidity that comes in over water that has a temperature in the 40s right now. So let's say you have 46-degree water in Long Island Sound and you get dew points in the 50s or 60s flowing over the top of it. That cold water will saturate the air, okay? And that will lead to fog and sometimes stratus clouds that can come rolling in during the course of the evening. So you may start out clear on a summer night, and then all of a sudden the fog and the low clouds roll in. And a lot of that has to do with what kind of humidity is flowing over the cooler water of the Atlantic Ocean or Long Island Sound. So that's also something that we look for, wind direction. When we forecast lows at night, we also have to take a look at the dew point, because the dew point provides kind of a cap. So let's say the temperature right now is 70 and you have a dew point of 35. Well, your relative humidity is very low. I mean, the air is dry. But as you cool that air down to the dew point, then your air, when the temperature gets down to 35, the air is saturated. So if you get really humid air flowing over cold water, it saturates that air. You can get dense fog at the coast. That stratus, which is a low deck of clouds, can work its way inland. And if that persists in the morning, that's when you get that very uniform, low-lying, sort of steely gray sky. So yes, things can happen in the evening like that, especially in the summer. It can happen in the winter as well. Or if you have an approaching storm, you may end up with, a nice sunny day. Then all of a sudden you get that veil of high clouds coming in, and the moon and the stars start getting dim. And, those clouds are up around 20, 25, 30,000 feet, but they effectively dim everything that's up there in the sky. So we live in a part of the world too where we're mid-latitude, and mid-latitude is where the jet stream spends a lot of time. The mid-latitude is where a lot of storms form, because if you think of a chimney, for example, and let's say you've got a fire burning in your fireplace. Well, if the air over the top of the chimney is blowing fast, it draws air in your house into the chimney. Your fire works really well because air is coming in. It's providing oxygen to your fire. That in turn is going up the chimney, and it's being evacuated by the high wind above the chimney. Well, weather behaves in a similar way. You get what they call these jet streaks, where you have a jet stream where the wind could be 100 miles an hour, and maybe in a very narrow portion of it, it's 120 miles an hour. Well, when the air aloft is blowing very fast, it causes air near the surface to converge and come in. And that's where, the air starts converging into a low pressure. So if convergence near the surface does not happen as fast as the evacuation of air aloft, the pressure near the surface drops, and that causes that convergence toward the center of the lowering pressure to become greater and greater. And that's how storms form. And here in the mid latitudes, that is a very common scenario, especially in the winter and the spring and the fall, when the jet stream spends more time in the lower latitudes. In the summertime, it retreats to the north. So in the summer, you tend, outside of thunderstorms and things like that, you tend to have less wind, and you tend to have less low pressure systems that move in. But in the fall, the winter, and the spring, things start to get a little bit more active. And this time of the year, a lot of people have told me, Bruce, why is there so much wind? And what causes wind, and it's true, I think over the years we've been seeing more wind, and a lot of people are really noticing that. And we've had a lot of windy days recently too. A couple of things that cause wind is a pressure gradient. So if you have a very powerful storm, not too far away from strong high pressure, because one builds upon the other. Low pressure is evacuating air in a column. High pressure is adding air, adding mass to a column. Well, if you have a very tight pressure gradient between those two systems, that accelerates the air and causes wind. The other thing that happens, and we saw it happen today, is if you have high wind speeds aloft, then a thunderstorm, which is really a giant mixing machine, because everything that's unequal in the atmosphere, the wind and thunderstorms try to make it equal, whether it's temperature, humidity, or whatever. But those thunderstorms can reach high up into the atmosphere, 20, 30, sometimes 40, 50,000 feet. And the downdrafts can bring those high wind speeds aloft right down to the ground. And that's something that we saw today. The other thing that causes wind here in Connecticut is this time of the year when you can get temperatures in the 70s and 80s and that water temperature is still in the 40s. Well, if you have hot air over land, which becomes very light and less dense, and cold air sitting over the water, well, that cold air is dense and it's going to come rushing right in and replace that warm air inland. And that's basically how a sea breeze happens versus what we call a gradient wind, which is driven by, the pressure squeeze between high pressure and low pressure. So if it's getting windier now, over the years, then that has to mean a couple of things. We're seeing higher wind speeds aloft that come down to the ground, or we're seeing more intense storms and more intense high pressure systems. So we spend more time in a very tight pressure gradient that causes wind. And it's something that, I haven't quite put my finger on, but I've noticed it. A lot of people are noticing it and sending me emails saying, why is it so windy lately? Not lately, but the last couple of years. So that's something I'm kind of playing around with right now. Maybe it's part of climate change, where we're in a windier scenario here in the mid-latitudes. We're about 42 or so degrees north and 70 degrees or so west. So we're right up there. In fact, that's one reason why Mount Washington has the highest wind speeds on the earth, is because they're mid-latitude where the jet stream spends a lot of time and there's no obstruction whatsoever to the northwest. So that wind can come howling in, and you can get those winds up there, 200 miles an hour or greater on Mount Washington. So, and we live in an area where, like I was saying with the Erica project, how the ocean interacts with the atmosphere to cause these storms to ignite like fuel, and it's what they call baroclinicity. If it's warm here, a pressure surface is high. If it's cold here, a pressure surface is low. Of course, you can't see the pressure surface, but like I showed you with the sheet of paper, it's there. So then that creates a pressure gradient and accelerates the air. But there's all kinds of things going on. I always tell people that if you could color, like I'm talking to you right now from the studio where we broadcast from, you might be able to see the news desk behind me. That's our weather podium where we handle severe weather from. But I often tell people, if you could color the air in the room, you would see all kinds of air motion, air sinking, air rising, air mixing. And you try to think of what the atmosphere looks like and try to color that once and see all the various motions there. So we're basically taking current data, and there's a lot of information from airports from around the world There's what we call, the balloons that are sent up to measure conditions aloft. The satellites now can take soundings of the atmosphere. There's a lot more data that comes in. In fact, that's why weather computers are the fastest in the world, because they have to handle a huge volume of data and get a forecast out in a reasonable amount of time. And that's one reason why the European model has been better than the American model at times, because they have faster computers to process the data. So it's a lot about how you can handle the data and process it to get that information out in a reasonable amount of time. So I'm kind of like, I get off on these tangents. I'm trying to think of where I was leading to. But yes, if you could, so you take all this current data and you plug it into an atmosphere or a computer model, and you try to portray what the atmosphere is going to look like hours from now and days from now and up to 2 weeks from now and so on. And, if there's a little bit of an error in that initial data, like let's say, for example, there's soundings that are taken in Buffalo, New York, and one on Chatham on Long Island. Of course, that sounding location has disappeared, but we'll use that for argument's sake. Well, those balloons go up and measure the atmosphere aloft, and then you try to grid the data in the computer models to find out what's going on in between. So it's kind of a guess. And if that guess has an error in it, with the integral equations involved, that error will get magnified with time. And that's why forecasting becomes less reliable, because an error gets blown out of proportion with time. So it can make the difference between a storm forming over you according to the forecast, but when the day comes, it could be a sunny day with high pressure over you. So so the thing is, if we can measure every cubic foot of the atmosphere and plug that data into the most powerful computer in the universe, you would get more accurate forecasts. But you can't do that with an atmosphere that's miles and miles deep and more than 24,000 miles around. So it's amazing that we can actually do what we do and become fairly accurate most of the time. There's times, I've been doing this 43 years. There's times I come in and I'm scratching my head. What went wrong? At other times, it's like, yes, it was a wind, because you're going against the models. And, like I go back to that 82 for next Wednesday. I'm taking a chance and going against the grain. So it's an amazing, very complicated science. And I kind of equate it to an infant. There is so much more that we need to know about the atmosphere. And another thing too is the ocean. We may know more about the atmosphere than we do the ocean. I mean, that goes down 30 some odd thousand feet in places. So there's so much that there's still to learn about this Earth. How far is global warming going to go before it snaps back and we're going into our next mini ice age? These are all questions that I ask and are very interesting. And so, it's a very young science. It's come a long way with Doppler radar and all these satellites that have better technology all the time, but we still have a long way to go. I always say that the more we learn, the more we realize we don't know. And it's very true, whether it's weather or astronomy or any other science.
Sure.
It keeps us going.
It keeps us young.
Keeps us young. There you go.
Thank you so much for presenting all these ideas and how to need more data just to get some concordance and what really is going to happen.
Well, you're very welcome. I know we've been trying to get together ever since the pandemic began. I know I'm probably for the better course of a year now, right? If I'm not mistaken.
Yeah. No, that's fine. I certainly appreciate you getting back to me. I fully understand how busy you are. This is the New England weather has keeps you hopping. I understand that.
Yep.
So
That's
again.
And when
it's
you
a
go,
lot of fun. I'm sure we all love what we do, and it's it's science, and they're inexact sciences. But you know, if you are sci-fi buffs and fans, I encourage you
Oh,
to
yeah.
watch For All Mankind on Apple TV. I'm not really much of a TV watcher. The one program that I did
It's a
binge
TV
watch.
weatherman.
Yeah, I know. When I'm at home, it's like no TV. No, that's not necessarily true. But I'm not much of a binge watcher or series watcher. The one series that I did watch recently with my wife, I have to say, is Schitt's Creek, and that was,
Oh, yeah.
oh my gosh, I love that. I would almost watch it again. But this series, if you're a science fiction fan, that seems pretty realistic when you boil it down. Then I encourage you to watch For All Mankind.
Yeah, I'll have to look
Really
that
good.
up.
Yeah, look it up and try a couple of episodes. It's really it kind of it's very scientific at times. At other times, it's very human, and that's kind of like why I like it.
Just gonna go around and see if anybody else has any questions.
Just gonna ask the same thing.
Yeah, Bruce, I have a couple of questions for you.
Sure.
The first thing I wanted to mention was when you talked earlier about your connection to astronomy, it made me automatically think of I'm sure everybody or most people here know who I'm going to mention. He's also has a connection to astronomy, and he's a colleague of yours. His name is Joe Rao.
Oh, is it Joe DeLeo or Joe Leo?
Joe Rao, RAO.
Oh, okay.
You recognize that name?
I have to say honestly that I don't. How do you spell it again? His last name?
It's RAO.
I don't recognize that name. I'm sorry. He's
Okay.
Yep. Is he?
Well, I know he's a meteorologist like you, and he's also got he's very passionate about astronomy. So
Is he in Connecticut?
I don't think so.
Okay, maybe
I don't recall what state he's from, but I know he's been at NEAF at least a couple of times.
I think he's New York or New Jersey.
I was gonna just say the same thing.
Okay. It's hard for me to keep track of everybody. We got Joe Fury, we got Ryan Hanrahan, we got Rachel Frank. I never get a chance to watch any of them because I'm doing my own thing, and I try to keep myself in a bubble. So maybe too much of a bubble at times, but
Just keep your astronomy passion up. I ran into Hilton Catterley at the train show at the Big E one year. He had some dealer holding up an HO model for him that was set aside for him. That was his passion.
Oh, he was so into trains.
Indeed.
Incredible.
I have a question from one of our observers here for you. He asked me to read it to you.
Sure.
Are still supercomputers used in weather modeling, or cluster computers taking over?
I'm not sure what the difference is, but right now they call them supercomputers, in my understanding. And they are the fastest computers on the planet Earth to be able to handle all that data. Yeah, so I'm not sure. I'm not really familiar with a cluster computer. We have, speaking of computers, I'm surrounded by computers here. And back in the Travelers Weather Service years, we had fax paper. We had maps that would come out on fax paper, and we draw all over them. And we didn't have, we had teletype machines clacking in the background. And what was a PC back then, or what was a cell phone, and things like that. So the technology changes.
Between those two would take fairly strong computers and connect them together. That would be clustering, versus a supercomputer like a big Cray computer.
Oh, okay. I do know that they used Cray computers. I don't know if that's still the case. The GFS model, which is the American model, which stands for the Global Forecasting System, that recently went through an upgrade. So they're trying to improve this all the time because they have to handle more and more data all the time, because there's more sources of data that come in all the time. And it's kind of like what I said before, the more we can measure the atmosphere from various sources, the more accurate our forecasts will become, and reduce that error, that guessing, that gridding that takes place between data points.
Ron, you want to ask that question? You want me to read it?
Yeah, I could ask it. Bruce, So I've noticed there's been an uptick in tornado activity in, Connecticut, Rhode Island, and Massachusetts, especially around the Cape Cod area, the last few years, and especially during the spring and the fall. And I know there's been some October, maybe even November tornadoes the last year or two. So do you think that could it be a link to climate change, or is it an increase in our weather technology, or both?
I think it's more of an increase in weather technology. If you look at over decades, I don't think tornado activity has really increased a whole lot. I mean, this year has been a bad year. There's other years that have not been as bad. But I think the fact that we have all this advanced technology where we can spot tornadoes. Now, there's a difference. We have equipment that would suggest, like an advanced Doppler radar, where you look at something and it looks suspicious and you issue a tornado warning based on the good technology. There's more tornado warnings now because we're able to see storms a lot better. We're using the Doppler effect, checking out what they call shear swaths and correlation coefficients and all that science. But it does not necessarily mean that it translates into more tornado verifications. There's more warnings, but not necessarily, in my mind, more verifications. But you are seeing unusual things like, more tornadoes on Cape Cod, and that you might be able to attribute to a climate change. But again, if you reduce the thermal contrast within the atmosphere, you're also reducing the fuel that causes storms to form. So it's something that we have to look at over, hundreds of years. How are things changing, and not just in the 115 years that we have climate data for Connecticut. It's not long enough to really come up with some really determined trends. But I will say this, okay. When we talk about normals, like I'll say the normal high for today is 62. Well, that normal is based on 30 years of data. So we're just getting through a period of data, normals that were taken from 1980 to 2010. That 30-year period was used to create the normals that we talk about. Now, normals are coming out that go from 1990 rather to 2020. Those normals are going to go up by an average of 1 to 2 degrees. So that strongly indicates to me that there's climate change going on. But will it translate into more storms? Well, I mean, look, okay, a couple of things that we have to look at too is the hurricane season. I mean, the hurricane season last year was horrendous. We went all the way into the Greek alphabet. Global warming, even though warming in a global warming scenario is slower near the equator and it's more dramatic near the poles, you are warming the ocean still. And we're what they call, I believe, a Atlantic multi-decadal oscillation, where the Atlantic water is warm, combined with the fact that last year was a year where we did not have an El Nino. And when you don't have an El Nino in the Pacific, it doesn't create shear that tears tropical systems apart in the Atlantic. Therefore, things were really free to form and, essentially go out of control. So we're kind of in a period now of increased hurricane activity. Part of it's due to warm water. Some of it has to do with dust that comes off the coast of Africa and things like that, which, that provides dry air that could kind of kill, hurricanes. There's so much involved, but we are in an increased activity period with the hurricanes, and I'm kind of waiting to see how things are going to happen this coming hurricane season, which, by the way, begins on June 1st. We'll tell you this, they also increased their normals for hurricanes. It used to be that the average number of named tropical storms in a season was 12. That for this year, beginning this year, it's now going to go up to 14 based on the averages that we've seen over the last couple of decades. So that's, I would think, if you see normals increase by a degree or two and they're upping the average hurricane season from 12 to 14, you have to believe that something's going on for sure.
And Bruce, if I could just follow up to that just real quick, because what you just mentioned about the hurricane season. So that leads to my second question, that what's your feelings about the fact that this year is the 30th anniversary of Hurricane Bob, which I believe was our last major landfalling hurricane in southern New England. And so I think everyone pretty much agrees that we're long overdue for another landfall.
The one thing that Mother Nature does not know that we're long overdue. We do say that we could go another 10 years without a major hurricane strike, or we could get into a situation like we did in the 1955 when we had back-to-back Diane and Connie that caused massive flooding in the state. It's just hard to know. You can get into that certain channel. What you look for is ridging in the Atlantic Ocean and troughing over the eastern United States that kind of acts to move those up the coast. But just a little fine twist in that upper wind flow. It's kind of like a log floating in the river. That log is going to go away and shift according to the current. And the same thing with hurricanes. You just don't know. You could have 30 named storms, but they're either to the east or to our south or to our west, or you could be right in that channel and get it. Well, look at back when Hurricane Andrew hit Florida. That was a low activity season, but that was a bad hurricane. So all it takes is one bad hurricane to make it a bad season, even though you have lower activity than normal. And you're right, it was Hurricane Bob back on August 19th, 1991. You want to hear a funny story? I know I'm going on and on and on with stories, but I was vacationing on the Cape, and there was a guy, the family next door at a cottage named the Madigans, and he worked for NSEP, and he was one of these guys that was involved in computer modeling. And sometimes basics work, all right? Basics do work when it comes to weather forecasting. Sometimes it just does not have to be complicated. He said, here we are standing on the beach, Onset, Massachusetts, which is the Upper Cape. And he was saying, yeah, you know what? This hurricane's going to take its normal path. It's going to move to the north and curve to the northeast and then go out to sea. And I said, you know what? I'm a little bit concerned about that front along the eastern seaboard that's not moving. It's staying put, which means there's no upper wind flow to move it to the east, which tells you that the upper wind flow is parallel to the front, okay? So it's the upper, if you have a front like this and a wind like that, your front's gonna go this way. But if you have a front like this and the wind aloft is like that, your front's gonna stay right there. So I'm saying, why isn't it moving? It's because the stream aloft, the current that guides hurricanes is from south to north. And I said, I'm a little bit nervous about this. Sure enough, I had to cut my vacation short and come back to Connecticut to track Hurricane Bob, which went right up over Block Island and Newport. So, yeah, it's, we're overdue. Again, Mother Nature doesn't know that. I think, given the fact that the Atlantic is going to be warm, what we have to look at for now is a mitigating factor like El Nino. El Nino, it's kind of like if you have a person 20 feet away holding one end of a rope and I'm holding the other end and I go like that, you're going to see waves travel along that rope. And it's all these things, and that goes around the entire hemisphere, because if you were able to look at an upper air pattern, it goes like this, dips and rises, dips and rises. Sometimes they're spaced out further, sometimes they're closer, what we call the wavelength. And things like El Nino, which are, yes, they're in the Pacific, but that warms the atmosphere above it, and that distorts that wave pattern, okay? And what it does is it creates shear in the tropical Atlantic. So when hurricanes try to form and they get sheared apart, they can't form. So one key ingredient, and I have to check into it to see if one is forming, is there an El Nino, which is unusually warm water in the equatorial Pacific against South America? Is there one forming, or is it going to be neutral? And they also affect the kind of weather that we have in the winter as well. But now that we're getting close to the hurricane season, which they were thinking about actually making the hurricane season start 2 weeks earlier and not June 1st, they did not do that this year. There's all these things that are coming into play because of all the changes in the normals over the last 30 years. So there's so much that comes into play with the tropical season, water temperature, shear, dust that comes off the coast of Africa, you name it. So I would kind of lean toward Connecticut shoreline back in 2012. I mean, we had Irene in August of 2011. That caused the worst power outage Connecticut ever had at that time, and it was a tropical storm. Then 2 months later, along comes a freak October storm before Halloween that knocked out 980,000 customers, 880,000 customers were without power. Then along comes Sandy exactly 1 year later in October, and that became our second worst power outage on record, all within the span of a year and change. So you could have a tremendous amount of damage that can occur with a tropical storm or even a winter storm. But I have to say that, I was talking to, I believe it was Kevin Nursick of the Connecticut DOT, said that if a hurricane of the size of the 1938 hurricane came along now, Connecticut could be without power for months. It could be that bad because, you're talking about 130 mile an hour winds that could gust. Like Blue Hill Observatory back in the 1938 hurricane had a gust of I believe 180. So that's a totally different ballgame. And you look at Connecticut, no matter where you go, there's trees. So trees, beautiful as could be, but when it comes to hurricanes, there's nothing worse to have than trees. And here in Connecticut, we have a lot of trees, and some of them are getting old. We had a very big gap between what Hurricane Gloria did back in 1985 that knocked out power to over 500,000 customers. From that period up through 2011, 2012, we had power outages and all that, but the trees during that period were pretty much allowed to get bigger, older, weaker. And then along comes a tropical storm, not a hurricane, and here you are, your worst power outage on record. So it's not only the type of storm that you get, but it's also the amount of trees that we have right here. Connecticut is one of the most heavily wooded states in the country, and that works to our disadvantage during high wind events.
Bruce, are you broadcasting tonight?
I am.
Do we need to give you a break? I mean, we could talk to you forever.
Oh,
You're welcome back anytime.
No, thank you so much.
I'll
tell you where we could leave it. I would, when it's safe to do so, I would love to come to one of your viewing events and, get a look through a modern telescope, instead of the dinosaur that I have at home.
What part of the state is home for you? You don't have to say.
Weathersfield. I live in good old Weathersfield, just 5.5 miles from Channel 3.
Oh, that's perfect.
Yeah.
I know.
Yeah.
Maybe we'll schedule something at that park near you.
Oh yeah, right down the street, Woken Hill.
I was thinking of the one near Chris.
That's Elm.
Oh, what do they call it?
Elmridge.
Okay.
Eldridge, because he's in Rocky Hill, right?
Yeah, I'm in Rocky Hill. Yeah.
Oh,
What
yeah.
did
that's where Channel 3 is located.
Yeah.
Right here in Rocky Hill.
Yep.
So that would be awesome. I would love to do that and be able to meet everybody in person. and, get, look through a fantastic telescope.
Yeah. Yeah,
We'd
no,
be
we'd love
happy
to
to share.
we'd love to have you. You're absolutely welcome.
Outreach is kind of our thing.
Yeah.
We do a lot of outreach as well. I love to hear stories. There was this one meteorologist. She was, and this is outreach and also going into classrooms and, talking to students. There was one meteorologist. She worked for the National Weather Service in Tucson. She may still be there. And she wrote me once and she said, Bruce, you came to my second grade class and spoke to us about the weather. I got hooked on meteorology and now I'm working for the National Weather Service in Tucson.
Wow.
And it's
Isn't that
things
great?
like that.
Yeah.
It's like, oh my gosh, that makes it all worthwhile, helping young people advance. I get interns very frequently. And one of the interns that I had in the past, Mike Cameron, who used to work here at Channel 3, was one of my interns. And another one of my interns way back when was Eric Fisher, who went from, he became a meteorologist on TV in Springfield. He went to the Weather Channel, and now he's the chief meteorologist at WBZ in Boston.
Wow.
He hit the big time, top 10 market, and he's very well known. But it's very satisfying, when you help somebody along and all of a sudden, years later, you hear back from them and saying, you know what? It was that visit to my second grade class that got me hooked.
Yeah.
Yeah.
I'm sure that every member here has got a story similar to that for their astronomy passion.
They're
Yep.
good stories, very good stories.
Well, if you haven't noticed the chat, there's been a number of people thanking you for the presentation. It was so well done.
Thank you very, very much, everybody. Thank you.
And
It's
again,
fun to
you're
just
welcome.
casually chat and
is.
talk about things,
You're welcome
It
to come
is.
back
It
and
is.
just
And it's
chat anytime you want without
Yeah.
having to put together a
Okay.
whole presentation.
Oh, well, you got it. When I do a weather forecast, I have to do it within 3 minutes. It's nice. It's nice to let a conversation breathe.
yeah. Yeah.
Yes. And
Well,
sometimes we do just that over a telescope.
Yep.
Yep.
And like I said, Massachusetts, Rhode Island, and Connecticut are definitely represented here.
Oh, excellent.
all right. Well, thank you,
Thank you
Bruce.
very much,
Thank you so
Bruce.
much.